All right, folks, let's go ahead and figure out the relationship between E, delta G, and K. We've been talking about K, the equilibrium constant, and delta G, Gibbs free energy. So we really want to start to relate E cell to this and talk about spontaneity in terms of the voltage. So first what we want to do is we actually want to define the voltage. We've spent some time finding the voltage of our cell, taking E cathode minus E anode. So now we actually need to figure out what a volt actually is. Well, a cell potential, you'll sometimes see this called a cell voltage or the electromotive force, but a volt is actually related to a joule. So if 1 joule is equal to a coulomb times a volt, and a coulomb is the amount of charge that's transferred whenever a current of 1 amp flows for 1 second. Okay, so an amp is equal to 1 coulomb per second. And to give you some idea of this, we could relate joules to watts. Okay, so that's power. And so watts is energy per second. Okay, so whenever you're looking at different types of traditional incandescent light bulbs, that's what we'd see, a 100-watt bulb, a 60-watt bulb. And this is related to coulombs times volts here. Okay, and so what we end up getting is a watt is equal to an amp times a volt. And then a 100-watt light bulb is about 110 volts, which is about 1 amp of current. So let's go ahead and see how delta G relates to E. So what we'll see is that the Gibbs free energy, delta G standard, is equal to negative NFE. Okay, and E standard here, this is just looking at E cell, what we've been calculating using the reduction potentials for the cathode and the anode. So here, N is the number of moles of electrons transferred, and we'll talk about how to get this. And then F is a constant. It's the Faraday constant. And this is 96,500 coulombs per mole electron. Okay, so here's an example of a problem. The standard potential at 25 degrees Celsius is 1.10 volts for this reaction, our favorite reaction. Zinc plus copper ion, copper 2 plus ion yields zinc 2 plus ion plus copper. So if we want to calculate delta G, what we need to end up doing is we can actually plug in. So we know what N is, because N is the number of electrons. Well, if we think about the two half reactions, we have zinc, okay, and zinc goes on to form zinc 2 plus, and it lost 2 electrons, whereas copper gained 2 electrons. So here, N is equal to 2 moles of electrons. All right, so let's go ahead and start to plug in. So delta G is equal to negative N, which is 2 moles of electrons, times F, which is 96,500 coulombs per mole of electron, okay, times E, which was given to us, 1.10 volts. So you may be given a problem where you actually have to find E for this reaction here. So after you plug in, we'll find out that delta G standard is equal to approximately negative 212,000 joules or negative 212 kilojoules. And since delta G is negative, this is a spontaneous process. And we will relate K and delta G and E to each other for spontaneous processes in just a second. One of the things I do want to point out to you is, let's say you end up having some reaction where you don't have the same number of electrons being transferred between each other. Okay, so let's say maybe you have something that looks like this. You have Au plus nickel 2 plus yields nickel plus Au3 plus. All right, so you would have to go through and balance this reaction, and what we'll end up seeing is after we balance it, we could go through and write our half reaction. So we have gold going on to form gold 3 plus 3 electrons, and we have nickel gaining 2 electrons, going on to form nickel. The least common multiple for the electrons is 6. So if we were trying to find delta G for this equation, in it would be equal to 6. So it's the least common multiple of the electrons. So you can start to pay a little bit of attention to the coefficients, but I would really just recommend that you write out the half reactions and then figure out how many electrons are being transferred. But then you would go through and account for E cell, which you'd have to calculate probably on your own, and then you also know Faraday's constant. So as we keep going forward, let's go ahead and talk about the relationship between delta G, K, and E. All right, so in this case, what we're going to do is we've already know the relationship between delta G and K. We know delta G is equal to negative RT ln of K. And we know that delta G is also equal to negative NF E cell. So if we set these two equal to each other, so if we have negative RT ln of K is equal to negative NF E standard of the cell, what we'll end up getting is this relationship here, is that E cell is equal to RT over NF times the natural log of K. So you can, if you're given K, you can find delta G, or you can find E the cell. And so you can find any of the other two if you're given one. So if you know K, you can find delta G and E. If you know delta G, you can find K and E. If you know E, you can find delta G and K. So what we want to do now is we finally want to talk about spontaneity for all of these. So let's go ahead and look at the signs of delta G, E cell, and K. Okay, so let's look at the direction of the reaction, and we'll talk about spontaneous or non-spontaneous. So if we have delta G is negative, so delta G is less than 0, it means that E has to be greater than 0, and K is going to be greater than 1. This reaction in the forward direction is spontaneous. Okay, another step might be whenever delta G is positive, so it's greater than 0, which means E has to be less than 0, which means K is less than 1. This is non-spontaneous in the forward direction. And finally, the last case would be whenever delta G is 0, E has to be 0, and K is going to be 1, and there's no net reaction. You're at equilibrium. So what this allows you to do is you kind of have an expectation for what your answer should be before you even complete the problem. So if you know that your delta G value is negative, you know that E has to be positive and K is going to be greater than 1. Okay, if you know that your delta G is positive, then E has to be negative and your K is going to be less than 1. If you're at equilibrium, then delta G and E will both be 0. All right, so that does it for our relationships between delta G, K, and E cell.